another is the trapezoidal area, right? So another is the trapezoidal area. So the more accurate is the trapezoidal area, because if we do the error analysis, that gives us the second order error, right? So we assume that we have data points and we want to find the integration. And how do we have the data points? How do we say that we have data points here, not the function, in this particular question? Anyone? Okay, so we have been given here that based on the numerical calculations, we use the equally spaced intervals, that is delta x equals 0.125 along a 3-meter beam. So we say that we have found the data at equal intervals of delta x equals 3 meter, delta x equals 0.125 meter, right? So from that we find the data of slope, and we have the data of slope with respect to x starting from x equals 0 at an interval of delta x equals 0.125. Okay, now we say that we have numerical data and we want to find the deflection, but how is deflection defined here? Deflection is defined as the derivative of deflection is defined as slope here. So we need to integrate the slope data to find the deflection, and we do it numerically. We have the data of slope versus x. We apply the trapezoidal rule here at every delta x equals 0.125 interval from x equals 0 to x equals 3, because we want uh, we we are given a range of 3-meter beam, right? Okay,
अरे
so
ऑनलाइन है तो क्यों कौन
okay, so from that we apply trapezoidal rule at every interval, and then we find the integration, that is the deflection at every interval, uh, right? And we find the slope, right? Slope at from 0 to 3. We can write the slope from x equals 0 to x equals 3, and we can also check it by calculating the um, also check our calculations, or numerical calculations. So we can find the error of numerical calculations by finding the analytical integration and putting y equals 0 equals y equals l equals 0. So we can find out the error also of our numerical calculations from. Are you getting it?
Yes, sir.
Okay,
So
so this is the first. Any questions in the first part?
the theta x function is given so that we could calculate error basically.
So error is the analysis part.
Yes.
So deflection is not error here. First of all,
So while we are integrating, right, we'll have to consider that we only have the data points.
yes, for numerical integration, we need to consider we have data points.
Yes.
And how do we find data points? We find data points using the formula.
Oh, yes. Okay.
So it is pretty straightforward here to find the numerical integration, and you need to show the error associated with numerical integration using analytical formula which is given, right? You can find the error easily. What is the final error if you calculate if you integrate the function and put the limits are 0 or 0 to 3. So you can check like that. Another thing is okay, so you can calculate the value of L also, yeah, right? Probably because you have the you can integrate it and you can put y equals 0 and y equals y at the rate L equals 0. You can find probably L also. So you need to see that. But the important part from the coding perspective is you need to write the formula of numerical integration at an interval of delta x equals 0.125 from 0 to 3. So that is the first part. The second part is numerical differentiation to find the moment and the shear. Now, so you know multiple ways to find numerical integration. Again, the same concept here also applies, that we have data points and we need to find numerically what is the moment at every point and what is the shear at every point, right? So how do we do it? I think that should be straightforward. Which method should we use it? Or can anyone tell all the methods that they have read in the notes?
Three-point difference method.
Okay, 3-point difference method. So what is the formula of 3-point difference method?
F dash x is equals to fx fxi minus 1 plus a1 fxi minus 1 plus a2 fx I plus a3 fxi plus 1.
So that is, so we need to find a naught, a1, a2 also in that one. But if we have 2 points and or if we have a series of data points and we want to find the differentiation, what we need is we have basically 3 methods, right? Forward difference, backward difference, or central difference. And we know that the error associated with all we know the error associated with all these 3 methods, right? These are the 3 basic methods, and the method of coefficients, which I think Rohit was telling, also result in the same thing. Basically, method of undetermined coefficients, it results in the same thing. And the 3-point difference method, right? 3-point difference method, we can so we can also see what is the error associated with all these 3 methods. The central difference method error gives a second order error, and the 3-point difference method also gives a second order error, but the relative amount of error is lesser in the 3-point difference method. Now you also need to find the second derivative here, which is the shear, right? So how do we find the second derivative?
So we can again use the method of undetermined coefficients.
Right. Undetermined coefficients on which part, on which data? So now you have movement and you have slope also.
So for the second derivative, can't we use that f of x plus 1 minus 2 f of x fxi plus f of x minus 1 divided by delta x square?
Yes, so I was talking about that one. So central difference method, we can find the second derivative also if you just expand the Taylor series of f of x I plus 1 and f of x I minus 1, right? And you just add it, you find the second derivative, right? And the second derivative you can find here, you can apply second derivative on theta to find the shear directly, but you need to balance out the coefficient terms, which is given here. The E and I are the coefficients. So you need to see E, I, W, not everything. You need to balance out the coefficients. Otherwise, you can apply the central difference method to find out the second derivative, which is V of X. And the central difference method is also applied if we subtract the Taylor series expansion, and we can find the first order derivative, right? Another thing, if we have the first order derivative, which means we have the value of m at every x from 0 to 3 or 0 to L, and we can apply any of these three methods to find v. So what would you do? So basically there are many methods available here, but the concept is simple. It comes from the Taylor series formula, and you have the actual analytical formula also. So you can find the numerical differentiation. You can find the numerical differentiation using all of these methods. You can list it out, okay, and you can find the differentiation using the analytical formula and put the values, right? And you can find the error, right? That would be the final error between the actual value and the predicted value using numerical methods. So in the report, you can also show the error using the analytical differentiation of the formula and double derivative of the formula to find v. So that's also simple, but you need to use all the three methods: the forward difference, central difference, and the backward difference to find the first order derivative. And using the central difference, you can find the second order derivative also. Using the data of m, you can find directly using any of the differentiation methods the v values, right? So you need to just compare it uh, and show that the um, error using the central difference method is lower as compared to the forward and the backward difference methods, because you have the analytical formula, you know the final error, right? Any confusion in that one? So I think I have just told a lot of things here. Any confusion? Right? So the only two parts are there, A and B. So I've explained both of them. You need to ask something, because I get a lot of doubts afterwards. So think about it for 5 minutes, and yeah, give me any doubts if you have. Also, if you have not seen the lectures, please see the lectures, so that will also clear up your doubts also, because these are very straightforward formulas.
So the numerical integration has to be done using the trapezoidal rule only.
So there are two methods given here. So trapezoidal is better, so you can use only trapezoidal, that's also fine. And if you want to compare it with the rectangular method, you can also try that also, because it's just a matter of applying one more formula. If you use trapezoidal,
Okay, sir.
that is a fine. Yeah, but you need to compare it with the analytical method and compare the find out the error and show it in the report. So that's what you have to do in report.
Yes, sir.
Also, one more thing I wanted to ask you. Have you all decided on your groups for the term paper? Have you all set up your groups? If anyone has not, just tell me. So tell me if some Excel sheet has been sent around so you can fill up your groups. So it's not been done. So I will send out an Excel sheet where you can fill up your groups, or maybe I will share a group. Maybe Excel sheet is better because then you can see who has not made a group, and people can find others for their group. So what is the number that you have been told that how many members can be in a group?
4.
4 members. Okay. So okay, so you will fill up the Excel sheet and I'll make it editable so you can fill up the Excel sheet. And some people, because some people asked me that they haven't found their group, so that will be helpful in knowing who wants some people. Okay, that's one other thing. And about the deadline, uh, we'll have to ask Jayati ma'am about it. So I've still not got the information. So I will probably ask this week. I will clear it up and yeah, post that also. So, and yeah, one more thing. Today is not any Viva, so there will be a Viva on Sunday of some people, right? For assignment 4 and 5 are done, right? So 4 and 5 most probably.
So will assignment 6 not come and dot 5?
Okay, so last assignment was assignment 6, right? So yeah, assignment 5 and 6 should be there. Yeah, assignment 5 and 6. The Viva should be on assignment 5 and 6. Or some. So anyone whose Viva is not yet done for the first time also. I think one person has not given the Viva. I know Manan. I'll have to talk to him. Other than that, anyone who has not given even one time. So those who have not submitted particular assignments, we have not taken their Viva when their chance was there. So other than that, so one more thing. So if you have not submitted an assignment, probably you were not called upon for Viva, maybe, or you did not show up for Viva. Uh, so it will not probably affect your other assignment marks, and every assignment is equally marked, equally evaluated. So that does not matter that much. But if you have submitted, you need to show up for Viva. So one person was traveling, I think, so he was not able to come. Otherwise, yeah, if you have submitted, you need to show up. I will send out the list of people who have their Vivas on probably Saturday night or Sunday morning, and will have the Vivas on Sunday evening. I hope you will not be in the break mood, right? Because I think break starts from day after tomorrow. So just keep, I think, 5 to 10 minutes aside for Viva. I think somebody was in a function last time when I had them for Viva. So keep aside 5 to 10 minutes for Viva on Sunday. I think 15 to 20 people would be there, not the whole class. So we have still got much time. So read the questions again. Just think about the procedure, what you want to follow in the assignment, right? And ask the questions, right?
So I had a question regarding the term paper. Like,
Term-
how do we search for the papers which we have to write?
So ma'am has not assigned any paper this time.
No, she
Ma'am-
hasn't assigned any papers. She did share some sample papers of
Okay.
previous years.
Right. So she shared some sample papers, right? So you need to open those papers. I will suggest that you read the abstract of the paper, right? And conclusion, at least the abstract and conclusion. So you don't have to go through the whole paper. And wherever you find something that you can understand a bit more clearly, right? So you follow something like that. So you don't have to uh, particularly follow any sample paper. You have to find out similar papers. And how do you find out? I told that already in a previous tutorial, that there will be many papers that use these numerical methods to solve the equations that they have got empirical equations, or they have got the equations using some physical concepts, or the concepts of chemistry. So they particularly use those equations and verify. And also, like I told you this time also, they get some data and they want to apply numerical methods to curve fit, or probably to find out the solution of the equation, if they have got empirical equations, or if they have not got any equations, they from the data they want to find out the derivative which gives them some physical variable. So you need to uh, keep a look on for that. So that part I think you can reproduce, which is applying those numerical methods on the data. Other thing is also, so one other thing is, many of the papers do not give data generally. So probably in the supplement information or supplemental paper, at the end of it you can find the link and probably find some data. If not, you need to find some data banks which can. So data banks are like, if you just email them, they can send you some data. So first what you need to do is you need to keep an eye on where the numerical methods are used. So that part only you will be able to reproduce, right? And after that you need to find the data. On the data you need to apply those numerical methods. So this will be a bit complicated process, because they kind of tend to use advanced numerical methods. So don't get I mean uh, don't get confused by that. If you give it some time, it will come to you naturally. I mean, it is probably understandable at your stage also. But if you find it difficult, try to find a paper in which you can understand it, right? And perform numerical methods, right? So read abstract and conclusion of the sample papers that man gave you. If you find it hard, you just find any type of paper which you like. Probably you may like something like uh, control parameters. If you so control theory. So control theory, you can find many types of numerical papers on control theory. Or maybe um, you can find numerical papers on reaction engineering, because we have profound formulas for that. We have abundance of data available for that. So think in that terms, right? So I hope I haven't confused you as much you have
No,
already.
sir, it's yes, sir. It's a bit clear.
Sir, can you reiterate what you said on which slope we have to apply the numerical method, integration method? Sorry.
Numerical integration in the TUT 7, right?
Yes, sir. Yes, sir.
The TUT 7, you have to just find out the data and apply integration on the data. to find out deflection, right?
We have to integrate a slope, which is whose slope, phi x or dm.
The slope, the formula of slope is given. Theta of x is the slope. Theta
Okay.
of x is the slope.
Got it.
So I think it should be clear. You need to apply all the three differentiation methods, and you need to apply trapezoidal integration methods, and you need to calculate the error using the actual value and the predicted value using numerical methods, and compare it, and yeah, analyze it in the report. Why is that amount of error coming? And try to differentiate between all the three methods with using the help of error. So next Wednesday you have tutorial, right? Or because the midsem holidays end on 19th, if I am right. Has anyone checked that?
Yes, sir. It is on 19, ending on 19.
So I next week also you should have tutorial. So next the deadline should be Tuesday night only.
So the 19, the coming Tuesday night.
Yes, 19th.
Okay.
And from the point of view of major exams, I think you should practice the error part, which is error analysis part from the lectures. I think that is important. Most probably that comes in major, because in our time I think it was there in major. So because this is not very straightforward what the error analysis is done here. Okay, so watch the lectures and yeah, practice that part.
So the majors will also be subjective,
Most probably major will be subjective. How are the minors? Was it subjective or objective?
and they are subjective.
Subjective.
Okay. Majors would most certainly be subjective only then. And okay. I think you have 1 more month, so don't worry about it too much. So you need to probably start with the term paper, and those who have not formed a group, so I will try to send the Excel sheet today itself and try to fill it up as soon as possible, because I need to assign some people who have not found a group.
तो मैंने सेंड कर दूं क्या? मतलब इसमें पहले ही काफी लोग ने फिल कर रखा था।
कहाँ पे?
मैंने बनाया था अपने तरफ से, तो फिर उसमें 8-10 लोग ने लिखा है कि वो लोग मतलब बेसिकली ऐसी शीट थी जिसमें पेज 1 में जिन लोग की टीम नहीं बनी है वो लोग करेंगे, और पेज 2 में जिन लोग की बन चुकी है वो लोग अपनी टीम से लिख रहे हैं। तो ऐसी एक्सेल शीट प्रिपेयर्ड है।
मैं शेयर किया था,
मैंने अपने ग्रुप मतलब कि हमारे ग्रुप में शेयर किया था।
तो इधर चैट में शेयर कर दो। एडिटेबल है
वो कर दो। आई थिंक हाँ एडिटेबल है।
चैट में शेयर कर दो। शायद कुछ दूसरे ईयर के लोग भी होंगे, दूसरे डिपार्टमेंट्स के भी हैं, तो उनको पता नहीं चला हो। सो ग्रेट न्यूज़, सार्थक के पास है लिस्ट। So again, if you don't have any doubt, I think we can end it. We will give it 5 to 10 minutes more, and yeah, give some thought on the questions.
जनरल चैट में शेयर कर दिया, देख लो।
हाँ ठीक है, सार्थक, ठीक है, थैंक यू।